Okay, in this series of videos we're going to look at some examples where we have to rationalise the denominator, and I'll explain what that means. But just a wee fact to remember: if we have root 3 and we multiply that root 3, our answer is 3. Okay, so that is a property it might be quite helpful to recall as we go through this video. Okay, so let's consider that we have to simplify the surd root 5 over root 2. When we're asked to simplify the surd, it will generally say in the question, rationalise the denominator. And what rationalise the denominator means is, here we have an irrational number. Here we have an irrational number. We want to do something in such a way that after we've done it, at the bottom we've got a rational number, i.e. a full number. Just a quick recap as well, I'm going to do this at the side. We can write the number 1 as a fraction. We can write that as 2 over 2, because 2 divided by 2 is 1. We can write 1 as 15 over 15. We can write 1 as 423 over 423. We can also write 1 as root 2 over root 2. And just another wee fact to recall: when you multiply anything by 1, you just get your original answer. You get your original question. So if we multiply this by 1, we're going to try and do it in a way that's going to rationalise the denominator. Our method when we are rationalising the denominator is we multiply by the denominator over the denominator. We multiply it by root 2 over root 2, because this is essentially just multiplying by 1, because we know that root 2 over root 2 is 1. So essentially we're not changing anything to our original fraction. We are just going to change how it looks. So at the top I've got root 5 times root 2, which is going to give me root 10. At the bottom, root 2 times root 2, I'm going to apply this property here, and on the bottom I'm going to get 2. I have now rationalised the denominator. The number at the bottom of my fraction, the denominator, is a rational number. It has an exact value. Okay, here we've been asked to rationalise the denominator for 8 over root 3. Okay, our process is that we're essentially going to multiply it by 1, but how we're going to write 1 as root 3 over root 3. Because if we were just to look at this, root 3 over root 3 is 1. Okay, I'm going to multiply my top numbers together. 8 root 3, and at the bottom, root 3 times root 3. Remembering the property from the previous slide, I'm going to get 3. That's us done. Okay, here we've been asked to rationalise the denominator 2 root 6 over root 2. We're still going to follow the same process, even though we've got this number here. Okay, so we're going to multiply this fraction by 1. But how I'm going to write it is I'm going to write it as root 2 over root 2. Okay, you're always choosing the number at the bottom, top and bottom. If this was over root 7, you would multiply it by root 7 over root 7. And we do that to get rid of this at the bottom. So at the top, I'm going to have 2 root 12. And that is going to be divided by 2, because 2 root 2 is 2. At the top, I can simplify root 12. I can simplify that to root 4 root 3. And that's all divided by 2. I'm just going to continue my working up here. We're going to have 2 times 2 root 3, which is 4 root 3 over 2. And we can cancel because things are multiplying. So I'm going to be left with 2 root 3. Okay, so when I got to this stage here, unlike before, this root 12 I could simplify. I could split it up into root 4 root 3. The square root of 4 is 2, so I had 2 times 2 is 4. 4 root 3 over 2, and the 4 and the 2 I could cancel down. Okay, here I've been asked to rationalise the denominator 10 root 5 over root 7. So I want my denominator and my final answer to be a whole number. Okay, so let's multiply this thing by 1. We're not going to change anything about it, we're just going to change how it looks. And how I'm going to write 1 is root 7 over root 7. I'm going to multiply the top together, the numerator, so I'm going to have 10 root 35. And at the bottom, I'm going to have 7. And I can't go any further. Okay, here I've been asked to rationalise the denominator 3 over 5 root 10. This one's slightly different because I've also got a number attached to the denominator, attached to the surd. Okay, but we're still just going to follow through the process. We are just going to multiply by 1, but how we're going to write 1 is we're just going to write it as this surd here. We're going to write it as root 10 over root 10. Okay, so I've not done anything. I've almost, even at this stage, I kind of feel like I've ignored that 5. So at the top, I'm going to get 3 root 10. Then at the bottom, I'm going to have 5. And then I've got root 10 times root 10. So I'm going to have times 10. And then simplifying that, I'm going to get 3 root 10 over 50. And I can't simplify that any further. Okay, I now have a rational number as my denominator. Okay, so I just carried this 5 down. Root 10 times root 10 was 10. I had 5 lots of it, so I wrote it as 5 times 10, which was 50. Okay, in this last example, I've been asked to simplify the surd, or rationalise the denominator of the surd 2 root 3 over 5 root 6. So we're just going to do the same as we did in the last question. We're going to multiply it by 1, but how we're going to write 1 is we're going to write it as root 6 over root 6. I am then going to multiply the top together, so I'm going to have 2, and then I'm going to have 3 times 6. And then on the bottom, I'm going to have 5. Then 6, root 6 times root 6 is 6. So I'm going to have 2 root 18 over 30. I can split 18 up into root 9 root 2 over 30. I'm just going to continue working up here. So that's going to give me 2 times 3 times root 2 over 30, which is 6 root 2 over 30. And 6 can go into this once and into 35 times, so I can complete my equation with root 2 over 5. 5 is a rational number. I have rationalised my denominator. So your method, you multiply the top and bottom by 1, but how you write 1 is this surd over this surd. You multiply the top, so 2, 3 times 6 would give me 18. You multiply the bottom, recalling the fact that root 6 times root 6 is 6. I tidied that up and I can split that in this example, and I followed it through, simplified, and I got root 2 over 5. Thanks very much.